Self-test. What does it mean? Split it. Built-in self-test. Built-in is something which is built into the chip or into the system. Self-test, which can test something on its own. Right? So we can design some logic, put some logic into the chip, which can generate some patterns. What we showed in our previous classes, we input patterns, and observe the output patterns, and compare the output data with the expected data. Then you say test is positive or fail. Okay. Now the test time is very important. We are going to see that very soon. So can we do the test pattern generation within the chip itself? Right. So that is the concept of BIST. We'll see that in very detail later. There's something called logic BIST and memory BIST. Logic will test the combinational logic and sequential logic, and memory BIST will test the memories, which is SRAM or ROM. There's a BIST to test the DRAMs also, the embedded DRAMs, but we will not cover it outside the scope of this course. So so you can read the statement by itself. It's very simple. Good to read that. Okay, so that is how the DOT can test itself. Okay, so let's see about the cost. Right? We saw a factor of 10 earlier, right? IC level it is assuming it's 0.5, whatever the unit. Board level it is 5 into 10 times. System level 10 times. Once the customer gives back the part with the issue, then cost increases multiple times. So it's a factor of 10. See how it works. So that's what it's saying. Testing itself is expensive. We'll see about the testing cost. Go to see this session or next session. Repair cost is much more than that. It's very expensive to repair anything. You say you bought a phone, you're out of the warranty. You have to repair the phone. How much time you repair or you buy a new phone? Questionable decision, right? So you look back, you have a TV repair or a laptop is repaired. Sometimes we repair it, sometimes we buy a new one, right? So we don't know. It depends upon the situation. Right? So these are some overall market to show why the testing is important, how much money people spend in testing, right? So this rough figure, currently the semiconductor market in the global is about $550 billion globally, right? And it's going to go to end of the year, it will go to $600 billion. Can you calculate that in rupees? And India is what? See the market in India, very tiny, 27 billion. It's hardly what 1/10. I don't know. You calculate how much it is, right? But India is it's going to rise. It's going to double in the next 6 years, next 4 years. So we are 2023, right? Next 3 years it's going to double. So there's a lot of market. So don't think recession. If you have skills, you'll get a job. People are not getting job. They are not skilled. They are not industry ready. That's a problem, right? So we have that. So you have to get the packaging. So it's very thin. So typically the packaging and testing cost is 15% basically. It's about 15%, right? So packaging and testing cost is 15% of the overall system cost. So it's pretty significant. So what are the companies involved in testing? So these are people are EDA tools. So there are the test tools, ATPG, Folsom, Synopsys, Cadence tools is what we use. We have Synopsys tools, Siemens, Hunter is a Siemens company now. Design houses, or Qualcomm, Intel, Texas Instruments, a lot of companies, right? They work on the design side. So they do a memory based, the services company, they do that. MediaTek, so many companies work on this. Manufacturing, we already saw about TSMC, everything we saw, right? UMC, Global Foundries, we saw names. So who does the testing? Let's see, right? So there are various companies that do various jobs. So how do we decide which is best result? I want the best out of everything, right? I want the best company, best salary, best job. I want best in the world, right? There's nothing called best. That's what you see here, right? There's no single best decision. So optimal decision is based on the technical issues plus economic issue. There is always a trade-off. Like you have to get something, you have to sacrifice something. What we say is no pain, no gain, right? Unless you work hard, you will not get the skills. Unless you have the skills, you will not get a job. Unless you get job, you will not get money. Unless you get money, you cannot do XYZ, right? So trade-off. So between the cost you spend for testing, the cost you spend for repairing your system. So there's something called trade-off. What is it? What is trade? What is off? Understand it, right? Pause the video. Understand the meaning of trade-off. This is extremely important. That anything you want to do in chip design is full of trade-offs. We call it as KPI, Key Performance Index. Key Performance Index. The performance, the test cost, yield, money, everything, right? Everything is money. Finally, business is all money. You have to make profit. That's the bottom line. Profit and loss. That's your bottom line, right? So there are different products that have different decisions based on the customer needs. So there is no single best solution for anything. Okay. What is the test cost? So it's profitable, I told you, right? Profit and loss. You have to make profits. If you don't make profit, you get layoff. You will not get salaries. You will not get salary hikes. So you have to work for company, right? You have to do your best for the company. Then only company will pay you more when you join the company. Right? So your business has to be profitable. So cost has to be managed appropriately so you can get profit. But there are trade-offs. You cannot compromise on the quality. Quality is very important. Can you do a less quality chip and get a focus, get more profit? No. You want good quality, good product, best price. You want to buy a shirt, go to a shop, right? How do you buy a shirt? You want a best brand, Raymond's or whatever, right? Park Avenue. You want best, card should be best, should work well, should get the design what you want. So there's a lot of conflicts. So there's a trade-off. And you have to do it on right time to the right market. You have to do TTM, time to market. We saw about it, right? You have to deliver on time. So test strategy is extremely important. So please write notes. I'll try and give an example to you. So you have to do this trade-off analysis. Take any design what you want. Maybe you can do as assignment or a case study in the end. Probably if you're interested, we'll do a case study. I planned it. I don't know how much you follow. You have to ask me questions, right? You can do a case study to understand how do we do the trade-off in industry. You can take a simple design. How do we save the test time? Test time is important. Tester cost is important. Area of the test logic is important. Right? Speed at which you test is important. Power is very important. Performance is important. Security is very important. You cannot, if you talk about boundary scan, I'll tell you about what is security. There's so many things called key performance index. The many things are important. Cost is important. You have to deliver it on time. How do you balance all these things? Conflicts, right? You have to be in the middle. Don't be in the extremes. Do the best what is required for the situation, for the particular customer. Ask right questions, take a decision, right? So that's what this is. Think stress strategy, tactics. Not even strategy, it's called tactics. Okay, rule of 10. Yeah, we already spoke about it. Let's skip the slide. The cost of testing, we spoke about it. It's going to increase the factor of 10. So high volume test, we perform doing ATE. So you can test a ATE or a package test on the ATE. We'll talk about ATE in detail. You can look at this particular cost of testing, this equation. It's pretty easy. You can do it on your own. Pause the video, understand it. If you don't understand, ask questions in the classroom as usual. Okay, cost. This is a simple example, right? This is a cost case study I was talking about. This is for example, but I'll do a real example. EDA tools are expensive. I don't know what the cost of the ATPG tools right now, but it's $10,000 to $100,000 USD whenever it was taken. For ballpark, you understand, it's not absolute numbers, right? So insert DFT, there's a cost. There's you got to invest on the people's salary. There's invest for the tools, invest for the area of the chip, right? For the DFT logic. Built-in circuit cost area, right? Cost that. Power, these are we just spoke about area, power, and delay overhead. About 5 to 10%, right? Overhead. Outsourcing, you could test it is about. It's a very you see the range, 0.5 million to $3 million US dollars. Is it not so expensive? Yes. ATE machines are expensive. You cannot regenerate the test patterns. It looks very simple, but I've worked on ATE machines myself 15 years before. Right? This is very challenging. Right? I'll get you there. If you're interested, I'll take you to a test house. It's all what you want, how much you can absorb. Right? That what are the three problems what we spoke in the class. Tested time per hour, it's about 300 US dollars. Test a chip for 1 hour to get the tested time. Right? And in terms of CPU time, the test time is very expensive. You put on the card and board and test, it's everything needs money. Can you do anything without money? You have to pay fees to the college, right? Now, companies are paying salary to you, right? You are paying money to the college now, right? College is paying money to me to teach you. Whatever is the money, right? There's a money involved. If they do it for free, will you do? Let's say college is giving a free education. Triple doesn't charge any money. It's a government institute. They can do a charity. But for required people, they give scholarships, right? Let's say, why don't we get all the students? Why don't they get scholarship? Government is doing free education. You go to primary schools get free education. Why not triple it giving free education? None of you take it for easy. You will not come to the class. Since your parents are paying money, they want something out of you, a return on investment. They're investing on you X number of lakhs per year, right? They want you to be happy. They want to succeed in the career. Yesterday I had a new mentee. I spoke to him, a fourth year student in one of the colleges in Chennai. Return on investment. Your parents are investing on you. What will you give back? I'm going to mentor him for 3 years. What will you give back to me? I asked him. Right? Return on investment. Right? Extremely important. Right? So it's all about balancing everything. How to make optimal decision? There is no right answer, no wrong answer. So there's no single best decision. You look at this equation. What is more important? Your testing. This is what your Indian go to any code you see that, right? Test and repair actually, right? So it's all trade-offs. You have to find an optimal solution. You have to be in the middle. Quality, don't test. You need best quality, right? But you want best quality, your test cost is very high. I'll stop there. I'll not go into detail. You can pause the video here, understand yourself, and ask me questions. So whether to do this again theory, forget about the equations. You can always refer, understand on your own. Go research on Google or ChatGPT, whatever you want. So typically, what I want to show is without DFT, your DPM is 6,000, where yield is 98%. FC is your fault coverage. We'll see what is fault coverage. Wait on few classes. We'll see what is fault coverage. Is 70%. DL is defect level, right? Defect level is so much XYZ, right? DPPM, right? So for this particular case, if you apply this equation, got 6,000 DPM. Is acceptable? No. But once you put DFT, yield is more or less same. Your fault coverage is increasing from 70 to 99. What is your DL? Defect level. This example, you apply this equation, calculate on your own 300 DPM, right? So DFT improves DPM. Economically, is DFT worth doing? Ask yourself. Is it designed for worth? Is it worth? Please ask yourself. Think, introspect, visualize, apply all the concepts what you read so far. Answer this. Take a ticket design. Break it down. Do a case study. Understand it. Is DFT worth or not economically? Because business is all money, right? Understand that. It is another example. So how do you prove that without DFT? Let you read on this one. You have to pause the video and read on the one, right? So number of dice without DFT is I'll not read. Let's go to solution. Profit, right? Sales minus repair cost without DFT is 387 whatever thousand number and 846 with DFT, right? You're going to have more profit, right? You understand all these things by yourself. So DFT is worth doing. I asked a question, you paused it, you got the answer right, you got it right. Okay, pause the slide here. Spend time to understand this logic. Numbers are numbers. You can put any numbers, but the P and L, I told you, right? Profit and loss. It's all economics, supply and demand. I hope you have read economics in your school and college, right? If not, please understand economics. You better understand what is economics, what is financial management. When you go to industry, it's all money. It's all money. It's all business. So how do you test wafer test or not? I'm going to skip this slide. It's a homework. You have to do it, right? The answers are here. You do wafer test, you package and do final test. So without wafer test, this is the money, and without wafer test, this is the yield. This is the money, right? So wafer test or not depends upon the yield. That's a summary. Pause the video here. Try and understand. It's all theory, but I don't want to focus on theory. You try and understand yourself. Homework. Okay, this all this is what again summarizing, right? We spoke about all those things. You can pause the slide here and read on your own. Nothing to explain here, right? We have to go based. We're going to talk about DTPG, DFT, yield improvement, better tools. It's like more like a story. You pause, read, understand, introspect, visualize. Any questions? Please ask me. These are research topics. If you want to do research on DFT, you can do. If you want to get on the industry and do a DFT, very yesterday I met a vice president of a big multinational company yesterday. I said, why don't you try your mentee on DFT? I told I want. So maybe all of you will get a job, a big MNC. But you have to do well. You have to get the skills. And don't go behind jobs and money. Go behind the skills. Do industry relevant projects. That's more important. You'll get a job. Somewhere you get a job. And this is again for reference. Where do you find research material? These are the IEEE journals where you can find materials. You can write papers on your own. You can do research.
Okay, let's talk about the testers. I'll spend about few minutes. I'll give you a lot of thinking time. I'll define what is a tester and leave the class in one more class where we can complete. One or two more classes, it's okay, you have to understand. Right? Tester is a device. Understand it. Let me read it out for a change. Tester is a device or equipment that applies the test vectors to a DOT, collects the responses, and compares them with the expected data. That is what is testing, we said, right? Exactly, this is called tester or automatic test equipment. It's called tester. You send an input, you get output, you compare, you have the stored data, you compare. Very simple, right? So device can be tested. What do you test? Your system, your board, a package chip, a die or a wafer. We spoke about all these things already, right? Are a kind of reinforcing, right? You can test one core. That's a design has something called core-based DFT these days, right? It's advanced concept. Will not cover. You have to understand what is DFT. So there are a lot of cores within the die. So let's have processor core, GPU, DSP, modem logic, right? Whatever, right? You can test that by one core at a time, right? A section of a core you can test. When you talk about JTAG and tap controller, we'll see if you can check that, right? But it's outside the syllabus, right? It's a black box. Whatever you test, you have to treat as a black box. I told what is control. I told you to take notes in the last class. Controllability and observability is very important, right? So do that. You are able to control and observe the device from outside the chip. That's extremely important, right? So let's see what this slide has. You're probably going to pause it here. With this introduction, you get too much. You know what is device under test, so I'll stop there. Test vector or test pattern, we spoke about it. Set of input values you could apply. One vector is test vector. Set of test vectors is called test set. You can refer to another textbook. One vector, you apply one input, one set of inputs, that's called test vector. I apply thousands of test vector together in a set, that's called test set. Stored response, you store the response, right? Test generation, you can generate a functional test pattern or a structural test pattern. Structural test pattern is DFT. Functional test pattern tests the functional behavior of the chip. Structural test pattern look for the defects and faults, right? So you have you need something called a good circuit model and golden model to test your design, right? So we need a golden model. You get the data, you store the data, you apply to your DUT, you compare the outputs. It is correct or not correct, you get to know, right? So I'll stop here. It's enough. A lot of work for now. We'll start with the test board and go on the next class whenever the next class happens. Wish you all the best. Please understand the questions, write your notes, ask questions in the classroom. Wish you all the friends. Bye bye. See you next time.